dear students. Today we have Proposition 10 of Book 4. Proposition 10 of Book 4. To construct an isosceles triangle such that the angles at the base are each double the remaining angle. This angle, double this angle, this angle, double this angle. To construct an isosceles triangle such that the angles at the base are each double the remaining angle. Let's set out a line. Let's cut it. There. Cut it such that the rectangle contained by the whole and the part, the rectangle contained by the whole and the part are equal to the square on the other part. We know we do that from previous prop. Given a line, to cut it such that the rectangle contained by the whole and the part is equal to the square on the other part. Let it be done. Okay, now let's take that line and let's swing it around, make a circle. We'll do it with this one. Hold the point fixed and swing this around, make ourselves a circle. Okay? Now, given a circle, to fit a line in that circle equal to a given line. Let this be the given line, and let's fit in this circle a line equal to this line here, this dashed line, okay? Roughly something like this, say. And let's dash this up so we can, in our mind, say, okay, dash line equals dash line. That's the way we're going to do this prop. Dash line equals dash line. Okay? Let's now connect these 2 points from the center. Right? Let's connect these 2 points where we cut this line originally and this point. Now, given this triangle, let's circumscribe a circle about this triangle. Okay? Circumscribe this triangle right here. Let's circumscribe a circle about it. We've proven that given a triangle, it's possible to circumscribe a circle about it. Okay? Not so ugly. Okay? Now, here you have remember, here you have a point outside of this circle, and a line falls on it, and a line cuts it clearly. We drew it as such that it cuts it. And another line falls on it from that same point. Does this line cut it or touch it? Let's see. We know that this rectangle contained by this and this is equal to the square on this. But this was drawn equal to this. Therefore, the square on this is equal to the square on this. But the square on this is equal to the rectangle contained by this and this. So therefore, the rectangle contained by this and this is also equal to the square on this. So here you have a circle, a line cutting it, and a line falling on it, such that the line cutting it, the whole and the part on the outside, is equal to the square on the other line. Well, we showed in the past that if there be a circle and a point taken outside and a line cut the circle and another line fall on the circle, that if the rectangle contained by the whole of the cutting line and the part outside is equal to the square on the other line falling on the circle, that line falling on the circle touches the circle. It's tangential to it. So this red line here is tangential to this circle here. And therefore, this line which cuts the circle, forming this angle here, let's say this color, forming this angle here, is equal to this angle here, because in this circle, this is the angle in the alternate segment of the angle made by the tangential and that line cutting the circle, making that said segment. Okay? So this angle here is equal to this angle here. If there be a circle and a tangent to it, and a line be drawn across cutting it, it makes an angle with equal to the angle in the alternate segment. So this is the angle in the alternate segment, so therefore this is equal to this. Let's add this to both sides. If this little angle equals this little angle, and this is common now, the whole will equal this plus this. So this angle plus this angle is equal to this angle plus this angle. That is to say, this whole angle is equal to this angle plus this angle. Okay? But now let's look at this angle here. And this, see this triangle? This is an exterior angle of that triangle. One triangle with this base extended, making an exterior angle to this triangle. And we know that the exterior angle of a triangle is equal to the opposite and interior angles, the two opposite interior angles. So this angle is equal to this angle plus this angle. Great. But this big angle is also equal to this angle plus this angle. Therefore, this big angle is equal to this big angle. Great. But let's look at this triangle right here. Keep focused. Let's look at this triangle right here. These are radii of this circle. Therefore, this is equal to this. Therefore, the angles at the base are equal. Therefore, this angle here is equal to this angle here. But this angle here is equal to this angle here. Therefore, this angle here is also equal to this angle here. Two things equal to the same thing are equal to each other. This angle is equal to this angle because they're angles at the base of the isosceles, and this angle was already proven equal to this angle because they're both equal to this plus this angle. Therefore, two things equal to the same thing are equal to each other. Therefore, this angle is equal to this angle, making this triangle isosceles. That is to say, this line equal to this line. Let's now dash it up to show that there's going to be equality. To remember that there's equality here. So this and this are equal. But this was fit into this circle equal to this. So if this equals this and this equals this, two things equal to the same thing are equal to each other. So therefore, this equals this. Dash line again equals a dash line. Therefore, we have a triangle with the angles at the sides being equal. Therefore, it's an isosceles triangle. Therefore, this angle is equal to this angle. So let's kind of do a little tricky thing here. Great. Therefore, if this angle equals this angle, twice this angle will equal this angle plus this angle. Remember that. If this angle equals this angle, twice of one will equal them both. This angle plus this angle equals twice this angle. But this angle was proven equal to this angle plus this angle because this is an exterior angle to it. Therefore, this angle is equal to twice this angle. But this angle and this angle were proven equal to this angle. Therefore, this angle and this angle are also twice this angle. And here you have a triangle, isosceles triangle, because the sides are equal, being radii of this circle. And with the chord fit in there, forming angles at the base, which are equal, which are both twice the other angle. We proved that this angle and this angle are both twice this angle. Therefore, we have constructed an isosceles triangle whose angles at the base are both twice the other angle.
Very cool prop. If you can do this prop, you are Euclidean. Quod erat demonstrandum. No, faciem. Thank you. Bye.